This is our Precalculus Spring 2017 ACP preview, trigonometric functions or ratios problems. And we're going to have a set of 6 problems here. They're going to be similar to what are going to be on your test here in a bit, a couple weeks. And what I'm going to do in these problems, there are going to be a lot of situations here about converting angles and radians to degrees. But this happens not to be one of them. And so it says, what is the exact value of the trigonometric function cosine of negative 870 degrees? So really the easiest way to do this is to, instead of over intellectualizing this, is just go to your calculator. In this case I have a T-Inspire CX calculator, and I go get a calculator page here, and I'm going to put cosine of negative 870 degrees. And when I do that, I'm going to look and make sure that my calculator is in degrees mode. And I go to the upper right of the view screen and I see yes, DEG for degree. And I hover over it, I get the degree in yellow pop up. So if I just press enter, I get this negative 0.866025, and I know exactly what it is, but let's go look at our answer choices. Well, we know it's not going to be negative 1/2 or positive 1/2, and we know that that's a negative number, so it's not that. So by process elimination, it has to be answer choice A. And just for confirmation, we can go back and put in negative square root of 3 divided by 2. And decimalized version, we get the same thing. So A is undoubtedly the right answer. So that's it. Next, problem 10. What is reference angle for an angle that measures negative 17 pi over 4 radians? And what we're going to do for this is, I've been teaching precalculus and calculus for 6 years now. And so radian measure is a lot easier for me right now. But I think for a lot of my students, to get this into degrees is going to have something you can work with better. So if we take this negative 17 pi over 4, we can convert this into degrees by multiplying by the fraction 180 over pi. And what we have left is pi over pi cancel. And you can just enter the whole thing in there and not even cancel the pi over pi. So we take, well, that's going to be negative 17 times, and then the 180 over 4 is going to be 45. Okay, and then I don't know exactly what that is, but we can go to calculator and put in negative 17 times 45, and we get negative 765 degrees. So negative 765 degrees. And really, for a reference angle, we have to get an angle. Reference angle has a possibilities, can be greater than or equal to 0 degrees and greater or equal to 90 degrees. So it's really going to be the smallest angle going directly to the x-axis. And what we're going to do this is get an angle between 0 and 360 degrees by adding 360 degrees. We have to add another 360 degrees, and so that would be 720. If we add 360 degrees a third time, we're going to get something we can use for a reference angle. So we take this negative 765 plus 360, okay, plus another 360, and we're still at negative 45 degrees, plus yet for one last time, 360 degrees, we get 315 degrees. So 315 degrees is going to be what we're going to use for an angle of center position to get our reference angle. And we're going to take I'm going to make a little circle there to evaluate trigonometry here. So if we go all the way around to 315 degrees, it's going to be right to here. Okay, that's going to be, I'll call it theta equals 315 degrees. And what we're trying to find out is this shortest angle to the x-axis. Well, to do that, we're going to take 360 degrees minus 315 degrees, and we're going to get 45 degrees. So that's going to be it. Now, if we look at, one thing you can do is you can also convert these angles here to degrees. Okay, so that qualifies. Now 3 pi over 4, when you work this out by multiplying by 180 over pi, you're going to get 135 degrees. That does not qualify as a reference angle. If you take 5 pi over 4, that's going to be equivalent to, let's see, that would be 225 degrees. That does not qualify as a reference angle because that's greater than 90 degrees. And the last one here, 7 pi over 4, well, that's going to be exactly 315 degrees, but we convert that, that is 315 degrees. So that does not qualify. So just by the size of the angles, these things right here do not qualify as reference angles. This is our only possibility, D. Next, 11. We have a cable holds 80-foot pole straight upright as shown, and so this is going to be 80 feet right here. That's the pole, and based on given information, what is the approximate length of the cable to the nearest 10th of a foot? Well, basically our trigonometric ratios are what come into play here. So we have the angle here, which is 62 degrees, and we're trying to find this side over here, the cable side, which is diagonal, which is going to be our hypotenuse. And this side opposite the angle, which is the pole length, 80 feet, is going to be our opposite side. So we're trying to find the length of the cable, and we're trying to find hypotenuse, but we have opposite. And we have the angle, so we should remember, I hope, that the sine theta is equal to our opposite over our hypotenuse. And so what that translates to here is sine of 62 degrees, 62 degrees, 62 degrees is equal to our opposite side, which we do not yet know, over our hypotenuse. Our opposite we do know, excuse me, our hypotenuse we don't know. And so we can just go to numerical solve right here, which I'm going to do later, but alternatively you can take the reciprocal of the sine function, which is I will show you now. Reciprocal of sine is cosecant. So cosecant is 1 over sine. So we can rewrite this thing as the cosecant of 62 degrees is equal to our hypotenuse over our opposite. And so our hypotenuse, therefore, by cross multiplying, is equal to 80 times the cosecant of 62 degrees. And I'm going to do that, but I'm going to do the numerical solve right here on this one. The sine 62 degrees equals 80 over hypotenuse. And how do we know we have a right answer? Well, the answer is going to be a little bit greater than 80. So sine 62 degrees equals 80 over hypotenuse. And we're going to numerical solve, menu 3(1), and we're going to say sine of 62 degrees equals sign, get a fraction, 80 over our hypotenuse, which I'm going to term h for hypotenuse, and come over to the right and put comma h. So we have an equation in terms of h, and we say comma h, which means solve for that h. When we do that, we get 90.6056. To the nearest hundredth, that'd be 90.61 feet. So we'll say here, hypotenuse is approximately equal to 90.61 feet. And then we could have also taken, as I worked out below, 80 times cosecant 62 degrees, see if we get the same thing. 80 times cosecant 62 degrees. And what do we get? Same thing. Shouldn't be surprising. So now let's go ahead. It says to the nearest tenth of a foot. And the nearest tenth of a foot is going to be 90.6 feet. That'll be our nearest tenth. So we're going to go in bubble in below. We're going to put 90.6. And so we just fill in our bubbles here. 90.6. Let's make sure I count right. 9.6. It doesn't matter exactly where it's put here in the bubbling procedure. It has to be, these 90 decimal point 6 have to all be consecutive someplace in this grid here. And so we have that. Next one, 9. What is the exact value of tangent negative 14 pi over 3? And this is very similar to this earlier problem 9 we looked at here, where we just put this directly in the calculator. But now we have this in terms of radians. So in our calculator, if we look at it, we are in degrees mode. So if we convert this into degrees, we're going to have something we can work with and make it quite easy, I hope. And so we're going to rewrite this thing as tangent, and we're going to put negative 14 pi over 3 and just multiply this by 180 over pi. Okay, so when we do this, we're going to have a decimalized answer, but an answer nonetheless. So let's just go ahead and go to our calculator. We go to tangent of a fraction here, negative 14 pi over 3, and to convert this into degrees. And how do we know we need to convert it into degrees? Because we have our calculator in degrees. Now if we went ahead and changed the calculator mode back to radians, we could fix it that way too. But anyway, we're going to multiply this by convert it to degrees by putting 180 over pi. And so now we're going to get our value right here. Well, 1.73. So they're definitely defined. And we go to look at our answer choices. Definitely not negative. Definitely not undefined. I think it's going to be square root of 3. So let's go here and put in square root of 3. And you're going to get a decimalized version here, which is the same thing. So undoubtedly now our correct answer choice is C. I think the square root of 3 over 3, I forget what that's going to be. It's going to be some other weird number. Definitely C is the correct answer. Next, 10. Which angle has a negative sine value and a negative cotangent value? And so this goes back to something we went over in our pre-calculus class here, where we look at our angles in terms of quadrants. Okay, we have quadrant 1 here, quadrant 2, quadrant 3, and quadrant 4. And we used a little mnemonic device whose title was All Students Take Calculus. Now, this statement here, all students take calculus, is definitely not a true statement, but it stands for this, that in quadrant 1, all trigonometric ratios are positive. In quadrant 2, sine theta is positive. And that means cosine and tangent are negative. In quadrant 3, tangent theta is positive, and in quadrant 4, cosine of our angle theta is greater than 0. And so to have a negative sine value and a negative cotangent value, well, negative sine value is going to happen right here. So this would be sine theta in this box here is going to be less than 0 or negative. And negative cotangent value, well, negative cotangent value is going to occur in two places. One here, and because cotangent is reciprocal of tangent. So cotangent can be negative here in quadrant 2 and in quadrant 4. So we'll say tangent theta is less than 0 here, and tangent theta is less than 0 here. And so basically it's understanding where these things are. We need to have the confluence of these two things, which is going to occur down here in quadrant 4. So any angle that gives us a measure in quadrant 4, and we can convert all these into degrees. And I'm just going to convert one of them because I think the only thing can be 7 pi over 9. So if we took 7 pi over 5, I said 7 5, and multiply it by 180 over pi. So pi over pi cancels. So 9 times 180 over 5. So we get 9 times 180 over 5. So we get 324 degrees. So 324 degrees finds itself over here in quadrant 4. So therefore, D is our correct answer. And you find these things in different quadrants. I think for answer C, you get quadrant 3. And for answer B, you'll get quadrant 2, and then totally wrong, pi over 7 is going to be in quadrant 1, which doesn't meet either qualification. So that's going to be how we work this one out. Now, we have 11. If cosine theta equals 7 over 25 and tangent theta is less than 0, what is the value of cosecant theta? I'm going to work this out two ways here. One, using Pythagorean identities and just identities, but the easier way to do this, I think, is using reference triangles. And so if we go ahead and take if we make an XY coordinate plane like this, we should know that cosine is equal to our adjacent side over our hypotenuse. So we talk about 7 over 25, we can just write our adjacent side here. I'll write this down along the x-axis. So we'll just say adjacent equals 7. Okay? And then we have an angle up here, and we'll say that our hypotenuse right here, we'll say hypotenuse is equal to 25. But it says tangent theta is less than 0. Okay, well, for tangent theta to be less than 0, let's go ahead and look back here. Our tangent is going to be less than 0 here in quadrant 2 and in quadrant 4. So what we have to have is to have tangent less than 0, we're going to have to be someplace else. If our adjacent is 7, we have to be going another direction. So instead of this angle here, we will go, we have an adjacent of 7. Okay, you see that I'm going here below the x-axis. We have hypotenuse equals 25, but here we're going to find this angle right here. But let's just go ahead. We have, it's kind of like we have a squared plus b squared equals c squared. So to get our cosecant, we have to find this opposite side, and that's going to be, let's see, 7 squared plus b squared, we don't know b yet, equals 25 squared. So b squared is going to be equal to 25 squared minus 7 squared. And so b is going to be equal to plus or minus square root of 25 squared minus 7 squared. So we go up to our calculator and we take 25 squared minus 7 squared, and we get 24. So our distance here is going to be, b is going to be equal to 24. Well, it's going to be plus or minus, but we're going down here, so we're going to take negative 24 in order to get our tangent negative. That's where we have to have it. And so anything that does not have a negative sign in it is just not going to be correct. And if you understand properly about what cosecant values can be, if we draw a number line here and go between, if we look at the possibilities for cosecant, between -1 and 1, cosecant does not exist. Our cosecant is going to have to be less than or equal to -1, or greater than or equal to 1. And so it's definitely impossible to have a cosecant value between those. So that disqualifies B. A is our only correct answer. And if we take, if sine theta equals, in this case, opposite over hypotenuse, -24/25, then cosecant is going to be a reciprocal of this, which is going to be -25/24. And then another thing you can do is you can use Pythagorean identities. I want to go right here to our ACP formula chart. You have a Pythagorean identity right here where you can use your cosine. You can take this cosine theta and make this, we have 7/25 squared, and you can solve for sine theta, and you're going to get 24/25. And it's going to be a little bit complicated, but we can, I guess I'm going to save that for another day, maybe talk about some of my students who are more interested in that for a particular solution. But anyway, these are all the problems we're going to work out. Again, a lot of converting from radians to degrees might help make this easier for you. Understanding what a reference angle is, the shortest, the smallest angle to the x-axis, no matter where you are in a standard position angle. So good luck all these problems, and as usual, thanks for viewing.